In this tutorial, we are going to discuss the main experimental research designs along with how to run paired samples t-test or repeated measures ANOVA with regard to experimental research studies. So I would like to share with you my experience of more than 10 years of doing research in an easy way. So experimental research designs are quantitative research designs, but they involve experiments doing pre-test and post-test. That's why we call them, for example, experimental, because we have the same group of the respondents or patients in different fields, and we do a test before the treatment and a test after the treatment to see whether or not there is an effect of that treatment on the performance or on the outcome that we are aiming to measure. So this is why we do experimental research, and this is why we adopt experimental research designs. Moving on to the types of experimental research designs, the first type is true experimental research design, which is the golden, let's say, or method or the standard method of experimental research, in the sense that we have an experimental group and the control group, or we call it the placebo group. So the experimental group is the group that receives the treatment, let's say the intervention, be it an educational intervention, a program of awareness, anything like this, or a treatment in the form of medicines, etc. And then we can have the control group. The control group is the group that did not receive any treatment of any kind. Sometimes we call it the placebo. And we use that just as a baseline to draw comparison between the experimental group and the control group. And we run a pre-test to check that both of them have more or less the same level, let's say, of grades or performance or proficiency or health conditions. And we implement the treatment on the experimental group after 1, 2, 3, 4 sessions, or after 1 week, 2 weeks, 3 weeks. And we do a post-test to see to what extent the pre-test and post-test showed statistically significant difference, and to what extent the experimental group and control group are different from each other using the independent samples t-test, or sometimes the one-way analysis of variance in case we are using more than 2 experimental groups. Let's say we are testing 2 different approaches of teaching grammar, let's say the inductive approach and the deductive approach, with a group that may not have been taught grammar at all, calling it the control group, to see which approach is more effective, the deductive or inductive way. The same can be applied to any, let's say, field. And we have this cause and effect relationship, and we have the manipulation of the variables. So examples include, as I said, the situation I told you about, or a randomized control trial when it comes to clinical practices. And this is the reference if you like to read more about this. Here we just have the experimental design, or the true one, that consists of a random assignment of cases and having control and experimental group. The second type is experimental design with the less stringent control measures, and it includes designs like one-shot case studies and one group pre-test, post-test. So we have just one group, and then we do pre-test and post-test on that group to compare their performance before and after the treatment has been applied, rather, okay? Then we have examples that include measuring student performance before and after new teaching method without having a control or placebo group. And this is a good reference by Campbell and Stanley, although it's a little bit old, but still it is really relevant. Experimental and quasi-experimental designs for research. Then we have the quasi-experimental research design, which resembles true experimental design, but lacks random assignment of the respondents or cases to the groups. So it is used when ethical or practical constraints prevent randomization, or sometimes we are afraid of, respondents or participants attrition or dropout. So examples include the impact of new policy in a community without random assignments. And sometimes we have a questionnaire that is using a quasi-experimental design by asking respondents about their opinion before and after they saw, for example, certain, let's say, video, or after they watched video, or sometimes after they saw certain pictures within the questionnaire itself. Okay. So this is what we call quasi-experimental design. Here we have a reference again by Cobb, Campbell, and Chadish, 2002. So it's called Experimental and Quasi-Experimental Designs for Generalized Causal Inference. Then we have factorial design. So this design involves two or more independent variables or constructs, and it examines their interaction. That's why we have interaction term. That's why you have sometimes repeated measures ANOVA, repeated measures within subject, and repeated measures between subject design, because we have this interaction effect that combines different combinations of variables. Then we have examples that include studying in the interaction of drug dosage and therapy type on treatment outcomes. Like here we have two conditions being combined together so that we can have a measure, or we can have an outcome that is measured accurately. Let's say taking medicine along with practicing sport, to what extent would that reduce, for example, the risk of having diabetes type 1 or 2, etc. Then we have this reference. This is design and analysis of experiments. Then we have repeated measures design. So the difference is that repeated measures design, we have sometimes three or more groups being, let's say, compared within a certain time of frame. Let's say we have pre-test, and then we have while test, and we have post-test. Here we have three groups: pre, while, and post tests. So the same subjects are exposed to each treatment, and responses are measured multiple times, meaning more than 3 times, or at least more than 2 times. It is useful for studying the effects over time, assessing the cognitive performance of a group of subjects and the varying levels of sleep deprivation. Here we have what we call reference by Maxwell, Delaney, and Kelly, 2017, designing experiments and analyzing data and model comparison perspective. Then we have the crossover design. This is less common, but it is used in treatments and specific sequence. The design is common, especially in clinical trials and case control trials. So we have study where patients receive both new drug and placebo in a sequential order. Now the difference between paired samples t-test and repeated measures ANOVA. So the paired samples t-test and repeated measures ANOVA, both are designs that test the pre-test and post-test, like the same group within different periods of time. The only difference is that a paired samples t-test, it measures two groups, like two periods of time, like two let's say periods, like pre and post, whereas repeated measures ANOVA tests more than 2, like 3 times, etc. And the difference again when it comes to assumptions, the paired samples t-test is based on normality, whereas a repeated measures t-test is based on assumptions like sphericity and other let's say assumptions. So let's just move to species.